Assalamu alaikum wa rahmatullahi wa barakatuh. Karibuni tena kwa channel yetu My Mastery Tutor, and this is what we're going to learn today. Today we're going to do this chemistry paper from Alliance High School. And again, just likewise, do subscribe to this channel. Subscribe to this channel. If you haven't subscribed to it, then subscribe so right now. It's a deep paper, Alliance High School, grade 10, end of term 2 assessment. And please share it to your friends so that they also can benefit from it. Now, again, I'll post topics on chemistry and also maths. I'll try my level best if I can finish all the topics, especially maths, chemistry, and also business. And also, I'll post other papers that you guys will want to see. Also, business, start with business, and I think biology. But let me think. I'm not a biology teacher, but I'm still trying on reading the content. So yeah. So if you haven't subscribed, subscribe right now. Now, question 1. Name 3 careers that require knowledge of chemistry and what each entails. So yeah, very easy question. Okay, we say name 3 careers that require knowledge of chemistry and what entails. Now, so we have a lot of careers, but the ones that I think you guys know is ones. The first one is career of pharmacy, or that is being a pharmacist, and this one involves preparing and dispenses. So it prepares and dispenses chemicals, medicines especially. So he prepares and dispenses medicine. So yeah. So just to okay. The second one obviously is a chemical engineer, and there's I think, if I'm not wrong, there's chemical engineering when you go to university. So a chemical engineer, basically what he does, he just designs and manages chemical manufacturing processes. So he's the one who designs and manages chemical manufacturing processes. So especially when you're trying to create the food, or maybe a medicine, or maybe anything involving a chemical in it, then he usually is the one who designs those processes so that you can get the end product. So what thing are you going to use? Which type of instrument, which type of machine should be used in creating a certain medicine or certain chemical? So he is the one who does that for the company. So many companies, like especially the pharmaceutical companies, they need to have an engineer, a chemical engineer, to do that whole thing or the whole work. Then we have a lab technologist or laboratory technologist. So from the name itself, or technician, but you can call him technologist. So normally he carries out the chemical test. So he carries out chemical tests. It's not a must for. We have a lot of lab technicians, not only schools but outside countries, inside countries, for the manufacturing companies. They also have. So some manufacturing companies have them. So carries out chemical tests and analysis of substances. So they analyze which type of substance is this, does it have alkene, which components are inside it, and etc. So so his main work is to do that. Now, question two: some young people in the community work long night hours in the transport, work long night hours in transport sector to stay awake. They frequently chew cat or mirror and drink highly concentrated coffee. So, state the active chemical component in coffee that is called caffeine, and I think most of you learners know that. So that chemical component, we call it caffeine. So the question B: describe two long-term physiological effects of this continuous lifestyle on the young workers. Is that the first one? They'll be very addictive to it. So they will be addictive to the stimulants. So they will depend, or you can write dependence or addiction to the stimulant, especially so it will be very addictive to it. Akiacha tu itamharibu yani akili yake pia, addiction to stimulants. So hata mara zingine kama hajapata cat, he'll try and find stimulants that are much similar to cat. Ndio maana utapata mtu ambao ya chumira pia, there's a higher probability that's also smoking cigarettes at one point or another. Now, the other thing is he's going to have a persistent high blood pressure, into persistent high blood pressure or increase in blood pressure. So atakuwa na shida yani blood pressure, atakasirika haraka, pressure yake iko juu, and he also has a risk of and increased risk of heart problems. And that is why we encourage to leave these things. So increased risk of heart problems. Kwa nini sasa? I don't know the reason why watu wapenda hizi ma drugs manini, itatuharibu at the end of the day. So yeah, question 3. Now we have a graph below that relates to element B. Now you've been told to use it to determine the relative atomic mass of B. Show you're working. The height of each peak is proportional to the relative abundance of each isotope. Okay. So what we know from the formula itself, you take the relative atomic mass. For you to get relative atomic mass, you take obviously the mass number, or let's say by the mass number. So the mass number of isotope 1 times the percentage abundance of isotope 1. You add to mass number of isotope plus percentage abundance plus times, let me rub that, times percentage abundance of isotope 2 plus mass number of isotope 3 times percentage abundance of isotope 3, then divide by 100. Okay. So what we take is the mass numbers. So if I want to calculate the RAM, itachukua the mass number of this, multiply to this. So I'll take 24 times 82.8. So yeah. And then I'll take the 25 times 8.1 times 8.1. And I'll take the 26 obviously times the percentage abundance, which is 9.1. So 26 times 9.1. And then obviously you divide it by 100. So I've divided it by 100. Wacha tuone itatupa ngapi? 24 times 82.8 plus 25 times 8.1 plus 26 times 9.1 is going to give us 2426.3. Then divide by 100, which will eventually give us 24.263, or let's just write it as 24.26. Is it hard? Nope. It's very easy, by the way. If you want, you can just write 24.263. It's similar. Question 4. State 3 key findings of Rutherford atomic model. Now, for the Rutherford atomic model, if you remember, he used something called a gold foil. And what he observed is that alipotumia hiyo gold foil na alipoweka hiyo, let's say this is the gold foil, this is the thing. So aliporusha hizo beams, he found that some particles deflected back 90 degrees and some were deflected back a little bit, ingine ikawa deflected back 90 degrees angle, and he found some particles just pass through it. So now the particles that usually pass through it, it showed that the nucleus is somehow has space. Now, space meaning that it's mostly empty. So there's an orbit that is usually empty. So most of the atom is an empty space. That's the first thing that he discovered. So most of the atom, okay, let me just wrap this. But most of the atom is empty space. And space too, yeah, may pass through, because remember, if this is an atom Obviously, this is a nucleus. If the particles just pass through it, means that V1 power equal in between the nucleus and the energy levels is mostly just space kabisa, kwa maana particles zika so it's mostly empty in short. So it's empty space. So most of the atom is empty space. So most of the mass is concentrated in the nucleus of the atom. And he also found out the ones that usually deflected back a little bit, and the one that deflected back at a 90 degrees angle, that is a little bit, and the ones that deflected back largely, okay, he found out that there's a nucleus inside. There's a nucleus, and that nucleus is usually very small and is dense, and it's a positively charged nucleus, and that is why it deflected. So some particles deflected. So the atom has a small, dense, positively charged nucleus. Now, charged nucleus. That's the second one. The third one. Now, the third one, he discovered that the electrons, so obviously, he discovered that electrons move around the nucleus. So the electrons move around the nucleus. That's when he discovered also there's an orbit and etc. So those are his three key findings. So let's jump into this now. Question 5. State two other atomic models. So the first atomic model is the Bohr's model. Okay, so this is the other atomic models. The other one is maybe the Thomson model. The Thomson model. We also have the one that is usually very known, the Dalton's model. So those are the three models that we have. So now, obviously, you know, the Dalton's model is the first one normally, and the Dalton model states that he discovered that a particle is usually round and spherical. But he didn't discover about the nucleus and the electrons yet. And then came the Rutherfords, where protons, where nucleus was discovered, and then Bohr, and I think Bohr is the second one, then the Dalton's model. But we'll look into those questions, so don't worry. Okay, I remember now. Okay, the first one is normally the Dalton's model. Okay, then followed by the Thomson. No, yeah, the Dalton's model. The Dalton was just describing how the atom is spherical, so ilikuwa hitaji mambo na electrons wala nucleus or anything like that, just describing the shape of the atom. Then came the Thomson model. It's called the Thomson, what do you call it, pudding or something like that. Now the Thomson model mostly discussed about electrons. He discovered mostly about the electrons. So he just discovered that there were electrons passing by through the nucleus. And then it came the Rutherfords. The Rutherfords discovered mostly about now the nucleus. Discovered that there was a nucleus which is very small and dense, and that is why those particles deflected somehow. And then came Bohr's model. He discovered that electrons are usually in a fixed shell. So he discovered about the orbit. So yeah, so that's just the summary. Now let's go to question 6. Draw the atomic structure of an element with an atomic number of 19. Now we know that atomic number, so your atomic number is the number of protons. So it's the total number of protons in the nucleus of an atom or in an atom. And the mass number is basically equal to the protons plus neutrons. Right. Now, if you want to find, obviously, you've been told to draw the atomic structure of an element with an atomic number of 19, which is has 19 protons and a mass number of 39. So it means that it has a mass number from 39. So we can search for the number of neutrons. Now let's search for the number of neutrons. You know that neutrons, if the mass number is protons plus neutrons, obviously, for you to get neutrons, take the mass number minus the neutrons. So at the end of the day, the mass number is 39 minus the number of neutrons, which is 19, is going to give you 20. Okay, so 20 electrons. No, 20 neutrons, sorry. So we have 20 neutrons. The other thing that we need to know, because we know the protons zetu ni 19 because of the atomic number. We know the neutrons now also. Our neutrons are 20. We also know now the electrons. The electrons is just in a neutrally charged atom. The electrons is equal to the number of protons. So if you have 19 protons, it means that you also have 19 electrons. Now, which element is that? An element with 19 protons. And that element, utaangalia kwenye periodic table yako from the formula. Hey, listen, BBC News on Friday night till you reach police canteen. Now, so ukifika mwisho at number 19, we have potassium followed by calcium. So calcium is at number 20. But for potassium, that is represented by letter K as a symbol. We know that it has 19 protons, 20 neutrons, and 19 electrons. Now, there's something called electronic configuration, because before drawing the atomic structure, we need to know at least the electronic configuration of potassium. And we say that the first energy level usually takes a maximum of 2 electrons. So from the 19, if you subtract the 2, you're going to remain with 70. So you haven't yet used all the electrons up. The second shell will take a maximum of 8 electrons. So 8 plus 2 gives you 10. So 19 minus 10, still you remain with 9. So then the third shell will also take 8, maximum of 8. So if you take 2 plus 8 plus 8 is going to give you 18. So from 19, if you subtract 18, you're going to get a remainder of 1. So the electronic configuration is 2881. So come here. Just rub this. Let's rub this. Come here. Sorry for that. And now this is your nucleus. Protons have how many protons? We have 19 protons. And we have 20 neutrons. And that, even though the nucleus is very big, this should be somehow small. Now come here. This is the first energy level, third energy level, the first energy level, second energy level, and then the third energy level. Though you're not supposed to use a compass, circles, the hands. So this is the nucleus. So you don't draw any electrons on the nucleus. This is just the nucleus. Okay. And this is obviously potassium, which is represented by K. Now let's see. So the first energy level takes a maximum of 2 electrons, which you can write here. One and the second one at the bottom. This one will take a maximum of 8. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay. We have 8 electrons also in the third energy level. And we forgot another energy level because in this electronic configuration it shows that we need at least 4 energy level because it has 4 periods. So at the end of the day, I need to add another one. Though I'm not accurate because I'm not using a pencil. But the fourth energy level just takes 1 electron. It just takes 1 electron. So now that is the structure. You don't put anything because it's not an what do you say it? It is not an ion. So, and the name of the element, obviously, we've said is potassium, which is number 19. Now, question 7, explain why an atom is electrically neutral. So, something that is usually electrically neutral, it means that the number of protons is equal to the number of electrons. So, in an atom, the number of protons is equal to the number of electrons. If they are not equal, then it becomes an ion. So an atom, the reason why it's electrically neutral, it is because of the simple reasoning that it has an atom has equal number, say has equal number of positively charged protons and negatively charged electrons. And negatively charged electrons. Okay, negatively charged electron. Sababu hata ukiangalia, let's say it has positive 19, sababu kuna hii potassium, it has positive 19 and negative 19. If you add them up, it should give you 0. 0 obviously is neutral to us, so it's not that hard. Now, question 8. Write the configuration of the following particles using both S and P notation, and box an arrow. An arrow, that is they want they want the orbital diagrams. So now magnesium, what is it? Sorry, magnesium is number 12. So number 12 meaning 12 protons, 12 electrons. But magnesium 3 plus, it is not, doesn't have 12 electrons. Though the protons would just be the same because it doesn't change. So 3 plus means that it has 3 more protons than electrons. So automatically it lost electrons. So if I take 12 minus 3, it's going to give you now 9 electrons. So magnesium basically has 9 electrons in its ion state. So magnesium 3 plus, you need to know at least first how many electrons does it have. So magnesium has 9. Magnesium 3 plus has 9 electrons. But if it was magnesium atom, then it's going to have 12 electrons. So now let's write the S and P notations. So obviously the first one we know is the 1s2. So itachukua maximum. The S orbital usually takes the maximum of 2 electrons. If you haven't seen my video, kindly look at my video in my playlist, or I'll put it in the last at the end of this video. So 1s2, and then followed by 2s2. Because even if you look at this, we've discussed this. We have 1s2, we have 2s2, then followed by 2p6. Just let's say for now, you don't need to do this. So we know that is followed by 1s2, 1s2, s2p. Then we have 3s, 3p, and 3d. So this one, then this one, then this one. So the 1s the first, then followed by 2s, then followed by 2p, then followed by 3s, then followed by 3p. That's how how it goes. So s usually takes a maximum of 2 electrons. So if it goes to the 2s, 2s will also take a maximum of 2 electrons. So if you look at it, 2 plus 2 is 4 electrons. So from the 9 electrons, you've used 4 in the s orbital, so you remain with 5 electrons. Now the 5 electrons will go to the p orbital, that is the 2p, so 5. The p orbital takes a maximum of 6 electrons, and therefore it is not yet filled. Now let's start with let's start drawing the orbital diagrams, obviously. So the 1s2, which is the first box, it will take the first and the second. That is the 1s2. The second one, the second box, is for the 2s2, which will also take 2 electrons. The third one, remember the p's will have 3 boxes. So, but first, according to the p's, remember mwanzo itajaza hii, so itajaza mwanzo, and then now you cannot do this. This is not allowed. So ati wafanye hivi, then wafanye hivi ndo ijaye yote. No, it's not allowed. First ingiza moja moja, and then ukiona ushaingiza moja moja, uingize ya pili. So that is how it is. So let's draw those 2 boxes for the p ones. So the P's are 3 boxes because it takes 6 electrons. So ya kwanza, ya pili, ya tatu. Sawa, lakini kumbuka yachukua 5. So ya nne na ya 5 tosha. And that is how it is drawn. Sawa, na lazima ziwe in pair hivi. Huwezi kati zote ziko one direction. You're not allowed to do that. Now let's go to the aluminium. Aluminium, obviously, aluminium atom is number 13, so it has 13 electrons. So very easy. Wacha tuanze na 1s2, 2s2, hizo ni 4 electrons add, 2p6, hizo ni 10 electrons, tabakia 3 electrons. So the other one is going to be the 3s. So 3s, kama ni 10 but 2, kwa sababu the s orbital takes a maximum of 2 electrons. So yamaisha sasa tuingia the p's, the 3p1. So umeona ni as easy as that. Now let's draw the orbital. Orbital yake itakuwa nyingi. Wacha to create some section hapa. Just know that it has 13 electrons. So 13 electrons hapa. So tumesema ni 1s2, 2s2, 2, 5, and now the S1, ngoja 2p5 ni 2p6. 2p6 kwa sababu 2 plus 2 plus 6 10, 2 plus 2 plus 1 13. So the p ikiwa ishakuwa fill lazima itachukua 6. So the p ni hizi hizi zote pia, ya kwanza, ya pili, ya tatu, ya nne, ya tano na ya sita iko tayari filled up. Then we go to the 3s2, pia iko filled up. So the 3s2 takes a maximum of 2 electrons. And then the 3p1, so in which utachora ya 3p utachora zote, lakini ile ambayo itajazwa ni hii peke yake. So hizi zingine ziko empty. Now let's go to chlorine. Chlorine is number 17, so 17 electrons as well. Nyingi sasa. So we have the 1s2, we have the 2s2, 2p6 is only 10 electrons. Then we have the 3s2, which is how much does it come? Is only 10 plus 2, 12. Then from the 12, so 17 minus 12 ni 5, so 3p5. Hata ukihesabu 2 plus 2 plus 6 plus 2 plus 5 itakuwa 17. Again, do the same thing. So utachora zile boxes. Where naenda kachora boxi ndogo, hii pia ni ndogo. Sawa. So ukihesabu is just the same as the one above, 1 2 3 4 5 6 7 8 9. Tuanze na S2. 1s2 obviously tayari shafil. 2s2 tayari pia tushafil. 2p6, so 1 2 3 4 5 6 tayari tushafil 2p6. 3s2 tayari pia tushafil. Now comes 3p5, so anza 1 2 3 4 and 5. Umeona imeleave hii hapa, kuna ka empty space hapa in which so katika hii third box it just has one arrow, sawa, sababu haijajaza yote. So that is that. Oxygen ni number hey, listen, B, C, news on number 8. So oxygen atom is number 8, lakini kwa vile kuna 2 plus, it means that it lost 2 electrons, and that is why you subtract 2 to give you now 6 electrons. So in short, oxygen 2 plus, number 8 ni oxygen atom. Ikiwa ni 2 plus, kwa sababu oxygen atom has 8 protons, 8 electrons. Ikiwa na 2 plus yamaanisha it lost electrons, and that is why it's going to be 8 minus 2. I'm repeating again so that everyone can understand. Oxygen atom in itself, oxygen atom ni number 8, in which yamaanisha ni 8 protons, 8 electrons. Lakini 2 plus yamaanisha it lost 2 electrons, and that is why that's 8, you subtract 2 and you get 6 electrons. Plus yamaanisha more protons, so electrons zimekuwa lost. Electrons are the negatively charged, the positive are the positively charged, so this means that the protons are more by 2. So in short, hii itakuwa ni 6 electrons, which is also very easy to construct or to write also. So 1s2, 2s2, so 2 plus 2 tayari ni 4, so 6 minus 4 tabakia na 2. So in the 2p orbital you just write 2. Sawa, and then kuchora pia ni rahisi, so 1s2, 2s2, and then we have the 2p which is supposed to be this way. Sawa, usisahau chora hizo boksi tatu, usichore hata moja ukaona. So 1s2 ni hii hapa, 2s2 ni hii hapa, 2p2 ya kwanza na ya pili, ya tatu haijajazwa. Sawa, unaona ni rahisi ikiwa hauko makini, yani waweza kosa hii swali. Now the Na plus number sodium iko number 11, lakini kwa vile ni plus it means it lost 1 electron to give you 10 electrons. So again 10 electrons, 1s2, 2s2, hizo tayari ni hiyo tayari ni 4, tabakia na 6. So hiyo 6 electrons obviously itachukuliwa na 2p orbital. So p orbital usually takes a maximum of 6 electrons. So again do the same thing, 1s2 imejaza, then followed by 2s2 pia ambayo imejaza, then p orbital ni hizi, so twende mosmos, 1 2 3 4 5 and 6. So khalas, tayari tumepata. So it's not that hard, it's very very simple. Question 9. Determine the number of unpaired electrons in a nitrogen atom. Determine the number of unpaired. Unpaired yamaanisha electrons ambazo haina pair. So a nitrogen atom, nitrogen, hey, listen, PBC news number 7. So number 7 meaning that it has 7 electrons. So ukiandika the SNP yafaa iandikwe hivi 1s2, 2s2, hizo tayari ni 4 electrons, 7 minus 4 ya kupa 3. So katika 2p orbitals itachukua ile 3 ambayo imebakia. So for the 1s2 ukichora diagram yake tayari ishakuwa filled. For the 2s2 diagram yake pia ishakuwa filled. For the 2p3 sawa, the 2p3 haijakuwa filled kwa sababu iko na 3 boxes, so lazima uende step by step, 1 2 na 3. So hii iko na ndio tunaita unpaired. So it has how many unpaired electrons? 3. So the answer is basically 3. Hopefully that answers our question, and the answer was nimeelezea pia. So 3 unpaired. So 3 unpaired electrons. Question 10. Write the electronic configuration for the aluminium ion. Electronic vile ni SNP2. So aluminium is number 13. Ion vile aluminium ni 2A3 is going to lose 3 electrons. Much easier to lose electrons, and therefore it loses aluminium imekuwa aluminium 3 plus but with 10 electrons. So in short, aluminium ion iko na how many electrons? Iko na 10 electrons. So aluminium ion which is 3 plus so which is by the way, sababu hujaambiwa very specific write the electronic configuration, watu wengi wangeandika hivi, but the most prescribed one kwa vile mafunzo SNP is just to write the SNP. So the if you write it in SNP notation, itakuwa sasa ni 1s2 kwa sababu ni 10 electrons. So ni 1s2, hizo ni 2 electrons tayari, hizo tayari total of 4 electrons, tabaki na 6 electrons. 10 minus 4 ni 6. So 6 itaingia kwa nimefanya nini? Itaingia kwa 2p6. So maximum of, so this is your electronic configuration, but I think no, but for now opt to write this kwa sababu most of your I'll see kama kwenye niaitwaje, kwenye curriculum design kama huwa wakubaliwa uandike hivi au tutakuwa tukisahau kitambo. So yeah, it's a 1 mark. So most probably if you write it this way you get a mark, a full mark. Imefanyika nini tena? If you write it this way you get a full mark. Question 11. How many electrons are present in the p subshell of a neutron chlorine atom? Hii paper ni mambo na SNP tu. How many electrons are present in the p subshell of a neutral chlorine atom? Neutral chlorine atom, number 17 means that it has 17 electrons. The SNP notation, utaandika 1s2 s that is 4 tayari. So then utaingia kwa 2p6, that is 10. Then utaingia obviously kwa 3s1, no 3s1, 3s2, then utaingia kwa 3p, ukihesabu 2 plus 2, hii ni 2 plus 2, 4 plus 6, 10, 12, utabakia na 5, so 3, 5. So how many electrons are present in the p subshell of a neutral chlorine atom? Okay, of a neutral chlorine atom, hii hapa ndo p. Katika p ya kwanza iko na 6, katika p ya pili very simple. Question 12. Draw the orbital diagram for the 2p subshell of carbon and explain the placement of the electrons. Now carbon is hey listen, BBC number 6. So carbon is number 6. So it's going to automatically have 6 electrons. Now, so write the meaning, the SNP going to be written as 1s2, 2s2, that's 4 electrons, and then utaingia kwa 2p2. So 2 plus 2 plus 2 is 6. So the orbital diagram for the 2p subshell. But let's draw the overall one. The overall orbital shell for the 1s ni hii, for the 2s is this one, nachora kubwa, and for the 2p is going to be 3 boxes because it takes a maximum of 6 electrons. So ya kwanza na ya pili. So in short, the answer, kwa sababu is very, very specific, you're not asked to write for this. So this is your answer for the orbital diagram for the 2p subshell. So this is your orbital diagram. So now the reason why we place it like this is because of a characteristic of something called Hund's rule. So in case you don't know it, you know it right now. Now Hund's rule says that electrons occupy separate orbitals. Occupy separate orbitals singly. So yani mwanzo lazima uweke moja moja, then utaziweka hii, utaweka ya pili with parallel spins before pairing occurs. as parallel spins, so yani ziwe hivi zote parallel spins kabla, so lazima iwe hivi mwanzo, then utaweka ya pili hivi. Huwezi weka ati ya kwanza ya pili hivi, ya kwanza na yakataliwa. So mwanzo lazima zote ziwe parallel to each other. Ukiweka ya kwanza, waweka ya kwanza, then waingia kwa box nyingine, waweka ya pili, waingia kwa box nyingine, waweka ya tatu. So they are parallel to each other. Now, so electrons occupy separate orbitals with parallel spins. Hizo ndio tunaita spins before pairing occurs. Kabla hata hiyo pairing haijaingia, lazima ziwe parallel to each other before pairing. Pairing occurs, pairing yani before it becomes something like this, you need to be having something like this first in each orbital. Now, hizo ni 2 marks. Question 13. Identify the element in the first 20 whose neutral atom has the same electronic configuration as a fluoride ion. A fluoride ion. Lazima tujue fluoride ion ni vipi. Fluorine is namba ngapi? Now fluorine ni number 7. Now, so number 7, so it has 7 electrons. So electronic configuration yake ni 2 5. No, I'm wrong. Fluorine ni number 9, not number 7. Fluorine number 9, so it has 9 electrons. So electronic configuration yake ni 2 7. So it's 2 7. So that's great. Fluoride ion sasa is much easier to gain. So kwa vile ni itakuwa F minus, it's much easier to gain than to lose. And that is why it's going to be 2 8. Now an atom or an element ambayo iko na 2 8 electronic configuration, ambao hizo ni 10 electrons, it means that that atom will have 10 protons. So iko number 10. Na ile ambayo iko number 10, hey listen, BBC news on Friday night, it's neon. So neon has 10 electrons exactly and 10 protons. So identify the element is that one which has 10 protons and 10 electrons, and that is neon, which has the same electronic configuration as fluoride ion, which is 2 8 as well. So seems very hard, but it's not hard. It's very, very easy. Question 14. Using knowledge of structure and bonding, explain the following. Question A. Magnesium oxide has a higher melting point than sodium oxide. Question B. Sulfur is solid at room temperature while chlorine is a gas at room temperature. Sulfur molecule, the hint is you've been given, has a mass of 256, while chlorine molecule has a mass of 71. Okay. So yeah, let's try it. Now, magnesium oxide, inside magnesium oxide, we have magnesium 2 plus ions. Sodium will have sodium plus ions. So the one that usually has a 2 plus has a larger positive, so yani iko na positive nyingi yani. So if it has a larger positive number, then it also means that it's going to have a larger or stronger nuclear pull. And that is why magnesium tends to pull the electrons towards the nucleus, and also it pulls the other ion, which is the oxide ion, towards it, and therefore the bond, which is the ionic bond, is much stronger. So in short, let's just summarize it. So magnesium 2 plus, uh, magnesium 2 plus, okay, or magnesium ion has a greater positive, so it's more electropositive, has a greater positive charge and stronger electrostatic force. So if it has a greater positive charge, so it means ni kama vile waika magnet mbili, magnet moja yavuta electrons, ikiwa lakini kuna magnet mbili itavuta hizo electrons much easily, and it's also going to because it is 2 plus, hapa itavuta hii negative charge much easily. So yeah, that is why if you have a stronger positive charge or greater positive charge, it will also mean that you're going to have a stronger nuclear force of attraction, or okay, and stronger electrostatic attraction. Stronger electrostatic attraction or stronger ionic bond, stronger electrostatic attraction, or you can say, let me grab this, attraction, or stronger ionic bond, or ionic bond, because the bond is the one that usually brings them together. So ionic bond to the oxide ions, the oxide ions. But you also need to compare. What about sodium? Okay, but once you just write it like this, is much easier. Sodium is the one that has a positive, and it has so let's just say this one, because it has a greater positive charge, and therefore magnesium oxide, magnesium oxide has stronger ionic bonds. So this is not a must, wacha nifute hii kwa sababu kuna electrostatic attraction. So electrostatic attraction to oxide ions, therefore magnesium oxide has stronger ionic bonds and require more heat energy to break it. That is why it has a higher melting point. More heat energy. So just let me explain it once more so that you can understand. Magnesium kuna 2+, sodium kuna plus. Ile ambayo iko na 2+, iko more positive. And since it has a great positive charge, it will attract the ion or the anion much easier. Kwa sababu it's going to have a stronger electrostatic force of attraction. While the one which is positive, even though it attract, but haito attract sana kuliko ile ambao ni magnesium ion. So if it attract sana, yamaanisha you require a lot of heat energy to break that bond. See, hopefully tumeelewana. Ni kama tu smaku mbili. If you have two magnets, this one will pull easily compared to one magnet. So question B, sulfur is a solid at room temperature, while chlorine is a gas at room temperature. Sulfur molecule has a mass of 256, while chlorine molecule has a mass of 71. Now, sulfur usually exists as S8 molecules. Okay, as S8 molecules. Okay, that makes it much harder to break it. While chlorine exists as Cl2 molecules. Cl2 molecules. And that is why you see the mass is very big for the sulfur one. Okay, so the S8 molecules are larger and have stronger intermolecular forces. Are larger and have stronger intermolecular forces compared to chlorine, because chlorine is only di. So stronger intermolecular forces, and therefore more energy is needed to separate those bonds. So more energy is needed to separate sulfur molecules. And that is why it's solid room temperature. You don't need to write a lot of composition. This is enough. So if you need more energy, yamaanisha yenyewe itakuwa ni solid form, separate sulfur molecules. So water, question C, water is a liquid at room temperature, while carbon dioxide is a gas at room temperature. Water, even though kuna non-metal and a non-metal, na a carbon ni non-metal and a non-metal. So hapo watarajia kwa covalent bonds, hapo pia watarajia kuna covalent bonds, na mbona sasa hii ni liquid na hii ni gas. Now, the truth of the situation is that water is not bonded using covalent bonds. It's bonded with the help of something called hydrogen bonds. So water molecules are bonded using hydrogen bonds. Carbon dioxide are bonded using to what we call weak van der Waals forces. So the hydrogen bonds are usually very hard to break compared to the weak van der Waals forces. Those that are covalently shared, they covalently share the molecules. They usually have weak van der Waals forces. So again, let me write here. Water molecules form hydrogen bonds between molecules, while carbon dioxide only have weak van der Waals forces, which are very easy to break, and that is why it's gas. It's a gas at room temperature. Van der Waals forces, or if you write intermolecular forces, you're also correct. Intermolecular forces. Okay, so the one that usually in bonds are much harder to break. Okay, so hydrogen bonding is harder to break. Thus, high melting point. Or let's say it requires more energy. You write harder to break kidogo itaonekana kama require more energy to break. So that is your answer. So very simple answer. Oh, let's go to the next question. Question D, diamond. Diamond is very hard while graphite is soft. Now, diamond, the reason why diamond is very hard, let me just describe the general reason. Diamond is bonded using the covalent bonds between carbon atoms. Lakini sasa uzuri wa diamond ni kuwa all the atoms are bonded with the help of covalent bonds. Hakuna intermolecular wala hakuna van der Waals hapa. For graphite, most of the molecules are bonded with the help of what do you call it, of covalent bonds, and they form layers. Now those layers usually bond with other layers with the help of weak van der Waals forces, and that is why graphite will tend to have a low melting point compared to diamond, because the layers are bonded using weak van der Waals forces, but the atoms making those layers are bonded covalently, and covalent bonds are much harder to break than the weak van der Waals forces of attraction. So in short, in diamond, the reason why it's very hard, in diamond, each carbon atom forms four strong covalent bonds. So carbon atom zote huwa form strong covalent bonds, while in graphite, three electrons are used in bonding, leaving one electron as the localized electron. So it forms four strong covalent bonds. Hakuna weak molecular forces wala intermolecular forces, hakuna kitu kama hiyo. In a giant three-dimensional structure. In a giant three-dimensional structure, or in a giant three structure. But in graphite, each carbon atom forms three covalent bonds. It forms three covalent bonds, leaving one electron delocalized that will be used to conduct electricity. So forms three covalent bonds, producing layers. So those layers are now held by weak intermolecular forces. So the layers are held together by weak forces and slide over one another easily. So slides one another easily, making it soft. There's a long explanation, but just shorten it. You don't need to write all of this. The reason I'm writing it this way is so that you can understand as a student. But you can shorten it, but the main general answers, you should describe this one. Lazima utaje hii. Let me use another one. I don't know why it's not working. Utataja hii. Carbon atom forms 4 strong covalent bonds. Now, and graphite pia utataja, it forms 3 covalent bonds. So these are the main key ideas. Producing layers here, and the layers are utaja 2 layers are held by weak forces pia tosha, and sliding over each other. Now, I don't know why I can't. Here tosha. So now draw dot and cross diagrams for the following. Now magnesium is a metal. Chlorine is a nonmetal. Metals and nonmetal react and they form ionic bond. Okay, so magnesium and fluorine reacts by forming ionic bond. So one will lose electron and the other one will gain an electron. So magnesium is written as 2A2, and if it loses an electron, it forms magnesium 2 plus because it's going to lose 2 electrons. Therefore, protons are more than the electrons by 2. Fluorine is written as 2,7 because it's under number 9, and therefore it is much easier to gain 1 electron than to lose 7. So if it gains 1 electron, it's going to become F minus. So moja ya lose, nyingine ya gain. So moja ya lose 2, nyingine ya gain 1. So just imagine, kwa vile ya lose 2, ita lose kwa hui fluorine. Because if someone loses, the other person gains whatever he lost. So huu jamaa ya gain moja. So ile ya pili itaenda wapi? Kwa sababu huyu ya lose 2 na huyu ya gain moja. Hii ya pili itaenda wapi? Ya pili itachukuliwa na another fluorine. So 2 fluorides will gain those electrons. So at the end of the day, ndio maana waona MgF2. So you have 2 fluorines that usually gain 2 electrons from magnesium. So this is just a summary of the answer that you'll find. But now let's try and do the structure. So you have magnesium 2 plus, which is and you're going to have fluorine minus, which is 8 as well. So wachachore, this is magnesium. This is the first shell or the first energy level, the second energy level. So the first shell, 2 electrons. The second shell going to have 8 electrons. So 1, 2, 3, 4, 5, 6, 7, and 8. And then funga hii kuonesha kuwa kuna ka 2 plus hapa. Then we have 2 fluorines. Wataandika tu nyuma yake 2 fluorines. So this is a 2 kuonesha kuna 2 fluorines, and then we throw the fluorine now. So fluorine pia itakuwa na 2 shells or 2 energy levels. So 1 and 2. But now don't use the same exact thing. Usitumie crosses. But instead use dots. So dots. Just imagine kuna dots hapa. Nisema tu mimi nimechora vibaya. But the first dot is this. Acha ni rapto so that ye kawa mjaelewa. So this is the first shell. So dot ya kwanza, dot ya pili, and then obviously dot 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 at x. The reason why nimeandika x ni kuonesha kuwa magnesium imelose ile electron to fluorine, so that's one electron that was lost to one fluoride ion, utaonesha as x. Now hopefully it is understandable. So and you write the minus here, lakini kumbuka muhimu uandike hii tu. Sawa. In case haujaandika, you can write it this way. You can write the magnesium ikiwa katikati and you draw another fluorine here. These are the other fluorine. Kutakuwa na minus ingine kuonesha one magnesium, two fluorine. So energy level hii ni nucleus, so sija ukaona ni energy level tu. So that you can also draw it like this. So yeah, that's one way, or you can opt to draw the way that I've showed you. Lakini bora tu hapa ni plus minus na minus hiyo hapa, isiwe ni plus minus minus. Ufai kuchora hapa something like this, ati hapa plus then kuna minus ingine. Unlike charges usually repel. So one plus on the right side ni kama kuna minus moja iwe right, nyingine left. So hopefully that is understandable. Let's try CF4. That is carbon and fluorine. Now carbon and fluorine, carbon is a nonmetal, fluorine is also a nonmetal. So both are nonmetals. And nonmetals, they bond through covalent bonding. They don't bond yani, they don't bond vile kama vile ionic bonding, because both of them are nonmetals and they share. Ionic bondings are usually formed when one loses and the other one gains. So carbon iko number 6, electronic configuration yake itakuwa 2,4. Fluorine iko number 9, which is 2,7. So hapa hakuna kulose wala kugain, they share. So for carbon, it needs at least to share 4 pairs of electrons so that it can be full, and fluorine the same thing, it needs 1 pair, so at least iwe 8. So waja hapa, and hapa si lazima uoneshe the whole shells, all the shells, bora tu uoneshe the outermost shells. So for carbon, this is carbon, nachora kubwa sana siku hizi, and this is carbon, and then we have hii first shell ni kubwa pia. This is the nucleus, this is the first shell. No, you just draw the outermost shell. Nimesahau pia. We just draw the outermost shell. This is the outermost shell. And then we have fluoride, fluorine. Nimeweka mbali pia fluorine. Then we have another atom here, forms a molecule now. This is fluorine. Now we said carbon requires 4 pairs. Okay, 4 pairs of electron. So this is and alafu umeambiwa CF4, yamaanisha utakuwa na 4 fluorines. So hii ni fluorine ya kwanza, fluorine ya pili, ya tatu na ya 4. So hii wacha nifute. Ya kwanza, so ya kwanza, ya pili, kwa sababu kila fluorine pia yachukua 1 pair. So something like this. Now fluorine ya kwanza yachukua 1 pair, ya pili pia itachukua 1 pair. So kila fluorine yachukua 1 pair. So 1 pair kwa sababu ya hii it requires 1 pair, na kuna pair nyingine hapa. So ukiona vizuri pia carbon imepata 4 pairs. Ya kwanza, kuna ya kwanza, ya pili, ya tatu. So ya kwanza, ya pili, ya tatu na ya 4. So those are 4 pairs. So since fluorine used 1 pair, yani itumia tu 1 pair katika kushare, so it means that fluorine imetoa 1 electron katika kushare, and the other electron was given out by carbon. So if you take 7 minus 1, you're going to remain with 6. So each fluorine will remain with 6 electrons. Taonesha hii dotted. So 6 electrons. So this 6 electrons, PP is 6 electrons. This is also 6 electrons, 6 electrons. Kila fluorine 6 electrons. Now 6 electrons, and that is your answer. Question C. Now question C, we have pH plus 4. So P is phosphorus. Say here, listen, phosphorus is around which one? Phosphorus and the sulfur. Phosphorus, if I'm not wrong, yeah, it's 285 because it's number 50. Supposed to be 285. Hydrogen is 1. Now, what you can do, now you might be wondering what is pH plus 4. Now, pH plus 4 is first is pH 3 plus hydrogen ion that doesn't have anything, and that is why you're going to get pH 4. One hydrogen ion that's why you have that H plus 4. So you have 3 hydrogen ion, one of them being positively charged ion, that is a. So you'll have 3 hydrogens that's going to equivalently share with the phosphorus, while the other one, which doesn't have an electron, because positive H plus means it doesn't have any electron outside, and therefore there will be a coordinate bond on the fourth bond with hydrogen and phosphorus, phosphorus donating it to hydrogen. Okay, so it's the one that gives out the electron, the share pair of electrons. Now let's draw the pH3 first. The pH3. So phosphorus 3 electrons, and this one is going to get 1 pair of electrons. So these are pairs, by the way. So 3 pairs. So 3 pairs and 1 pair. 3 pairs and 1 pair. So let's draw it. Let's draw the pH3 first. So we have phosphorus, which is again, this is phosphorus, and you have the 1H, the second H, okay, and the third H. And draw it very efficiently. And the third H, which is this one. Now for that becomes pH 3. So one hydrogen will take 1 pair, the other one also 1 pair, the other one 1 pair as well. This one is very small. Let me just rub it. Well, even though it should be still the size, so this is 1 pair. Now for the fourth one, obviously, so that is the for H3, we've done with the H3 and the phosphorus. Now if it has 3 pairs of electron, so if you take 5 minus 3, it's going to remain with 2 electrons. Now this is the 2 electrons outside. Now what it does, because this is pH3 and you're going to add H plus H4 so that you can get pH plus 4. So the other hydrogen, which doesn't have an electron, hydrogen ion, remember hydrogen has 1 electron. If it's an ion, positively charged especially, is going to lose 1 electron, it's going to have 0 electron. So that one which doesn't have any electrons forms a coordinate bond with phosphorus, and therefore phosphorus is going to give these 2 electrons to hydrogen, but at the same time they're going to share it. So you have something like this. Okay, so yeah, so that is going to be, just assume there's nothing here. Let me just rub this so that it doesn't confuse you. So this is plus. Now the plus is because of the hydrogen ion. Hopefully is understandable. Once more. Now let's come to question 16. Write the formula of the following compounds. We have ammonium chloride. Ammonium, which is ammonium ion, is written as NH plus 4. Chlorine, which is chlorine, this one, chloride, chlorine. So normally ammonium chloride, ammonium is going to have a valency of 1, because of that charge. This is a radical. So this is a radical, so it's going to have radicals, a group of atoms with net charge, and react as a unit during a chemical reaction. They act as a unit. So it's going to, because of it has a plus, the, what do you call it? The valency would be 1. Chlorine is number 17 because it's 287. So the valency is 1 electron. So again, you write the valency here. So your valency here is 1. They're going to interchange, and therefore you're going to get NH4Cl. So that is the easiest, but the correct method, it should be this way. That is, you get NH4. So you have Cl. But let's say this is plus, this is plus, Cl minus. So this one will take the valency of this, chlorine will take this, and that is why you're going to have NH4Cl. You don't put any brackets, don't write it this way. Okay, so you don't write it like this. Especially most of the students might write it like this, which is not the case. Just leave it that way. So yeah, that's your answer. Mercury is written as Hg, and nitrate is written as NO-3. Nitrate has a valency of 1. Mercury, because it's written mercury 2, this one usually represents the valence, and therefore you'd write 2 there. So ukipata kama silver 4 ama silver 2 nitrate, the 2 represent for the valency of so hiyo mercury 2 nitrate, the 2 represent the valency for mercury. So again, the Hg takes the 1 Hg, and the nitrate, the whole nitrate takes the 2. So utaweka in bracket. So that is your answer. Now, sodium hydrogen sulfate. Sodium ni hii. Hydrogen sulfate is also a radical with a valency of 1. So valency 1, sodium valency yake pia ni 1. That's something that you should know because equal group 1 element. It also is number 11. It has an electronic configuration of 281 and therefore loses 1 electron, and that is why the valency is 1. So the sodium normally takes the 1, the hydrogen sulfate takes the 1. So it's going to give you sodium hydrogen sulfate. So that is your answer. Sulfur 6 oxide. Okay, sulfur 6 oxide, sulfur and oxygen. The valency for sulfur valency yake kwa sababu ni number 16 ni 286. Valency is therefore 2 because it's going to gain 2 electrons, so valency ya 2. Oxygen iko number 8, so it's going to be 26. Pia yeye ata gain 2. Now typically you could have written that way, but this is wrong. Okay, why? Is because sulfur valency yake ushapewa tayari ni 6. Ya oxygen valence ni electron, valence ya oxygen ni 2. Sawa, so kuwa makini, mara nyingi wapewa swali kama hili na huwa itakuchanganya. So most of the students what they do, wataenda kwa sulfur watasema valence ya sulfur ni 6 and valence ya sulfur ni 2, wacha tuandike 2. Is wrong. So hapa valence ya sulfur ni 6, valence ya oxygen ni 2. Now all of them are even numbers and you can simplify. Waweza ukadivide na 2 ikakupa 3 na ukadivide na 2 hapa ikakupa 1. So at the end of the day, the sulfur will take the 1, the oxygen will take the 3, and that is why sulfur 6 oxide is written as sulfur, is written as SO3. So that is your answer, question 17. Mambo na kubalance. Napenda maswali kama haya. Sawa. Now, ukiangalia vizuri, twende step by step. Balance the following equation. Iron 3 oxide plus carbon 2 oxide plus iron plus carbon 4 oxide. So twende mos. Sawa, wacha tuandike iron, wacha tuandike this is the reactant, and we have Now the reactant kuna ion, kuna oxygen na carbon. The product pia ion, oxygen na carbon. Kuna ion mbili on the reactant side ukiangalia, oxygen ni 3 plus 1 is 4 oxygen. There's one carbon. One carbon. On the product side kuna one ion, one carbon and 2 oxygen. So ukiona upungufu uko kwa ion na uko kwa oxygen. So utakuja hapo kwa uko kwa upungufu uko kwa right hand side. Sawa. So ikiwa kwa right hand side ukiandika hapa 2, ion itakuwa 2 na oxygen ukiandika sasa, shida sasa ya oxygen ni kuwa sawa, acha tuweke. Ukiandika 2 oxygen imekuwa 4 lakini carbon sasa imekuwa ni 2. So tena upungufu unakuja kwa carbon. So itabidi sasa tuweke carbon hapa 2. Ukiweka carbon 2, oxygen tena sasa tayari ishakuwa 5 na hapa ion imekuwa 2. Sasa upungufu tena unakuja kwa oxygen now, especially on the right hand side. Sawa. Now if we do this, ukibadilisha 2 ukiweka 3, sawa, ukiweka 3 sahihi, sasa itakuwa carbon umebadilisha kabisa na oxygen pia umebadilisha. Oxygen sasa itakuwa ni 6, carbon itakuwa ni 3. Sawa mpaka hapa. So upungufu tena inakuja kwa oxygen na carbon, lakini on the reactant side kwa sababu ziko less. So waja pahali ambapo kuna ion na oxygen, and that is this one. Sawa. Is this one here. So tukiweka tu na upungufu iko kwa oxygen na carbon, sorry. So waja kwa kitu ambayo iko na oxygen na carbon. So tutatoa badala ya 2 tuweke 3. So hapa tayari itakuwa na 3 carbon, 6 oxygen kwa sababu 3 plus 3 ni 6 oxygen and 2 ion kama kawaida. So is it balanced? Yes, it is balanced. Ona tumeenda step by step mpaka tukapata answer yetu. So you can do this the other way also, the other question with the other questions as well. Waenda tu utaratibu, use the longer way, but at the end of the day utapata answer. So ion 3 oxide plus 3 carbon 2 oxide is going to give you ion plus 3 carbon 4 oxide. Now let's come back, let's go to second question, which is lead sulfide plus oxygen gives you lead oxide plus sulfur 4 oxide. So again kuna lead, kuna sulfur, kuna oxygen. So jua tu hiyo ni reactant, hizi ni product, lead, sulfur na oxygen. So lead kuna moja, sulfur moja, on the reactant side kuna moja, oxygen 2. On the product side lead moja, sulfur moja na oxygen 3. So now if you look at the oxygens, they are usually uangalia vizuri, moja ni odd, nyingine ni even. So we are prescribed in chemistry to have even numbers. Sawa, to have even numbers. So it's better hiyo ya oxygen ambayo ni 3 uifanye even hivi. Sawa, uifanye even. So the best way sasa kuifanya even upande wa right, even though itaongeza idadi ya oxygen. So ukiweka 2 hapa tayari ishakuwa nini? Ishabadilisha lead, imekuwa na 2 lead na umekuwa na 4 oxygen sasa na 1 sulfur. Sawa. Sasa maanisha upungufu kwa lead, sulfur na oxygen. Sasa tunaenda sasa kwa lead na sulfur. Ukienda kwa lead na sulfur, utaweka 2 hapa. Ukiweka 2 kabisa, lead 2, sulfur 2, oxygen 2. Then sasa upungufu sasa unakuja kwa lead na oxygen. Oxygen tukiweka 2 hapa, sawa. Upungufu hapa sulfur. Sulfur iko sawa, iko nyingi kwa upande wa reactant side. Sema tu shida ni oxygen. So 2 oxygen ikipiga 2 times 2 itakuwa ni 4 hapa. So on the reactant side oxygen ishakuwa 4 na ishakuwa 4 on the product side. Shida sasa ni tu hiyo sulfur. Sawa. again kuna shida hapo. Ukiweka 2 tena sasa imekuwa na 2 sulfur amino oxygens, 2 times 2 4, 4 plus 2 6, so itakuwa 2 to 6. Oxygen sasa iko na upungufu on the reactant side and therefore utaweka 3 hapa. Umeona tayari ishakuwa balance hata ukiona, so itakuwa na 6 oxygen, 2 lead, 2 sulfur. So niangalia tu ishakuwa balance na mapema. Acha nifute. Nimeenda long way lakini bora tu nimefika. So lead sulfide. But the other way pia ilikuwa nikifanya hivi pia ingekuwa rahisi. So kwa sababu hapa sulfur na oxygen, wacha tu. So tayari tushapata answer. Kwa nini tena turegee? Hebu ngoja tu turegee tu, sababu kuna misconception nataka kuitoa, kwa sababu hii naona ni long method. Lead, we have lead, we have sulfur, we have oxygen, we have lead, we have sulfur and oxygen. One lead, one sulfur, two oxygen, one lead, one sulfur, three oxygen. So tumeona hapa ni shida, hapa ndo shida pia. So what we normally do, that's the easiest way. Eka 3 yako ije hapa multiply na 3. So hapa wacha tuweke 3. So tayari ukiweka 3 ishakuwa ni 6. Sawa. Na ile 2 ambayo ilikuwa hapa multiply na upande huu. So utaweka times 3. Sawa. No, not times 3, times 2, sorry. So utaweka times 2. So let's see now how it balances itself. Mitihani screen yangu inaanza kujizimazima. So let's see how it balances itself. Hii itakuwa na 1 lead, 1 sulfur, 6 oxygen, 1 lead. How many oxygens are those now? 5. Okay, and 2 sulfur. So again shida iko kwa sulfur. So tukiweka 2 hapa itakuwa 2 lead, 2 sulfur, so itabidi tena tuweke 2 hapa and it's balanced. So itakuwa ni 2 lead, 2 sulfur, 6 oxygen and it's already balanced. Na upande huu pia itakuwa 2 lead, 6 not 6 sulfur, 2 sulfur, 6 oxygen. So balanced it already. Tuje hapa. So tuiandike tu vizuri, 2 lead sulfur plus 3 oxygen, you're going to get 2 lead oxide plus sulfur. By the way, nafaa uweke pia hizi nini, hizi symbols. Sijui kwa nini hawajakuwekea, but usually is prescribed to put it. So hii ni solid, hii ni gas. Potassium chloride. Potassium chloride, let's go step by step. Hapo sasa tuifanye kama hivi: potassium chloride, hydrogen na kuna kitu inaitwa sulfate. Siandike sulfur na oxygen kando, otherwise itakoroga. We have potassium kidogo chalala. Say potassium chloride, hydrogen and sulfate. The same thing, potassium chloride, hydrogen and sulfate. Kama barrier hivi. Potassium 1, chlorine 1, hydrogen 2, sulfate 1. Just have 1 sulfate on the reactant side. Potassium 2, chlorine 1, hydrogen 1, sulfate also 1. So upungufu uko kwa hydrogen, okay, so hydrogen and also potassium. Potassium is less on the reactant side, so tutaweka 2 hapa, wewe 2 potassium, lakini chlorine tena imebadilika. Then we have 2 hydrogen and 1 sulfate. Kuna upungufu pia kwa hydrogen, so utaweka 2 hydrogen, so imekuwa 2 hydrogen, 2 chlorine, 2 potassium and 1 sulfate. Is it balanced? Tayari shakuwa balanced and we've finished with that thingy. Tumeenda tu step by step tukapata, otherwise ingekuwa hapa tufikiria hii ni so potassium chloride plus this is maybe solid, okay, plus sulfuric acid is solid. Sulfuric acid aqueous, you react it, you dissolve it, and you're going to get potassium sulfate, which is aqueous because it dissolves, plus HCl, which is also aqueous. So now another one, silver. So again, we have silver, we have nitrogen, acha tuweke nitrogen na oxygen. Then there we have silver, we have nitrogen, we have oxygen. Huwezi weka nitrate kwa sababu on the product side hakuna nitrate. So silver moja, nitrogen moja, oxygen tatu, silver moja, nitrogen moja, oxygen sasa hapa ni 4. So the main thingy is this. Sawa. So what are we going to do? Sasa tukiweka 2 tu hapa balance, ishamaliza kila kitu. 2 silver, 2 nitrogen, 6 oxygen. So tuweke 2 kwa silver, 2 silver, nitrogen tuweke 2 nitrogen, lakini oxygen ishakuwa ni 6. Is it balanced? Tayari balanced. Kumbe ukienda step by step wapata answer yako, sio? So 2 silver nitrate which is solid, utapata silver, 2 silver plus 2 nitrogen for oxide which is gas plus oxygen gas. So balanced. The last one, that is N2 plus H2 gives you NH3. So ask yourself the same question: nitrogen, hydrogen, nitrogen, hydrogen. 1, 2 nitrogen, 2 hydrogen, 1 nitrogen, 3 hydrogen. So upungufu uko kwa nitrogen, so tuweke 2 hapa, itakuwa ni 2 na hapa itakuwa ni 6. Sawa. So itabidi sasa tuweke 3 hapa, itakuwa hapa ni tayari iko balanced. So unaona kitu kigumu, lakini huwa ni rahisi ukizoea tu, yawa rahisi. So nitrogen plus 3 hydrogen gas, and then it give you it also gives you a gas, ammonia ni gas. So balanced. Question 18. We maswali haya lakini alliance utaona ni ni rahisi. It's somehow easy and tricky at the same time. Ikiwa hauko makini, yani utajipata umefeli sana. That is question 17 done with question 18. Question 18 ukiona is a practical question. So, and the questions asks you that Alana from Alliance High School discovered a new element from the school farm. He called it Busherian. Where you ni kali. He gave it chemical symbol Bu. On further analysis, it was found to be below potassium in the periodic table. Option A identified the mistake in chemical symbol of Busherian and suggests the correct chemical symbol for Busherian. Sasa kitu ambayo amefanya, ameandika small b capital U. When you are writing for a symbol, the first letter should be a capital letter. The second letter should be a small case letter. So this is the right chemical symbol. So that is the mistake that he did. Now, most of the students, hiyo pia nataka nifunze something also regarding this matter. Whenever you're writing the symbols, nimesema the first letter is usually a capital. The second is a small. So wanafunzi wengi wakiandika chlorine symbol huandika hivi, which is still wrong kwa sababu hatujui yani hii ni small l ama ni capital L. So to just avoid that, let's stop writing this way and write capital C small l that way. Na wala usiandike hivi, utaona sasa sijui hii ishakuwa L kubwa, L ndogo, Allah alam. So another thing is upande wa aluminium pia the same thing, watu wafanya hivi. Instead it should be written as this way. Now, and that is one thing. Yeah, the other thing is copper. Bone kuna blackout tu kwenye hii screen. Copper ni hivi. Wanafunzi wengi waniandika hivi sasa. Sasa this I don't know if these are small capital. I don't understand what is this. So capital C small u. Ioneshe at least small u. Sasa ukiniandikia u kama capital sitoelewa. So that is the answer to this question is capital B, small u. Now name the chemical family. Name the chemical family in which Busherian belongs. And kwa vile it's found to be below potassium, so obviously it's going to be in group 1. So ikiwa in group 1, and group 1 elements are normally called alkali metals. So alkali, the chemical family is alkali metal. Sawa, sababu tutajua alkali metals. So kwa mfano lithium, sodium, na hapo chini umeambiwa it is found to be below potassium, na hiyo kuna Busherian. So obviously these are group 1 elements. Sawa. Busherian reacts with water to form Busherian hydroxide and hydrogen gas. Write a balanced chemical equation for the reaction. Now Busherian is a group 1 element, so Busherian solid plus water, which is H2O. So this is liquid, is going to give you Busherian hydroxide. Lazima ujue Busherian hydroxide inaandikwa vipi. Capital B, small u, hydroxide ni OH minus, so iko na valency ya 1. Group 1 elements have a valency of 1. The same goes to Busherian. So BuOH, it takes the 1 and the hydroxide takes the 1. So it's going to be written as Bu capital O capital H. Hydroxide zote ni capital. So because this is a radical. So it gives you an aqueous solution because group 1 elements usually dissolve in water to give you a basic solution. So Busherian hydroxide plus hydrogen gas. Again, if you look at this, look at it, we have 3 hydrogen. We have 1 Busherian, 1 oxygen on the product side. We have 1 Busherian, 2 hydrogen, 1 oxygen on the reactant side. So let's balance it. So 1 Busherian equals sawa. The only problem ni hydrogen. Hapo on the product side kuna 3 hydrogen. On the reactant side kuna 2 hydrogen. So upungufu iko kwa reactant side, and therefore we put a 2 here. We'll have 4 hydrogen and 2 oxygen. Kwa vile tuko na 4 hydrogen, sahihi tuko na excess oxygen by 2. On the product side, which is here, hakuna 2 oxygen. So we need to add 2 here. But so ukiona tena, it gives you 2 hydrogen plus 2 hydrogen, 4 hydrogen, 2 Busherian, and you also have 2 oxygen. So 2 Busherian on the right side. You also need to have 2 Busherian on the left side as well. Now that is the balanced chemical equation. Reaction. Write the formula of sulfate and nitride of Busherian. So Busherian kuna sulfate. So sulfate yake. Sulfate is a radical of 2 minus. Busherian iko na valence ya 1, sulfate iko na valence ya 2. So Busherian itachukua 2 and the sulfate will take the 1. So it's going to be written as this way. That's Busherian sulfate. Nitride. Busherian, kuna tofauti between nitride and nitrate. Sawa. Katika nitride, for example, umeambiwa Busherian nitride, kuna 2 elements peke yake. Kuna Busherian, kuna nitrogen peke yake. Nitrate formula yake Busherian nitrate, kuna Busherian, kuna nitrogen na kuna oxygen. It represents the presence of oxygen. I, it represents the presence of 2 chemicals. So Busherian nitride is Bu and N. Now nitrogen has a valency of 3 kwa sababu huwa iko hey this and BBC news, that is number 7, iko kwa 2 5. So it is easily gains 3 electrons to be an ion, so 2 8. It's much easier to gain 3, so that's why the valence is 3. Busherian group 1 element, so valence yake bado ni 1. So it takes the 3 and the N, and therefore you're going to get Bu3N, and that is your answer. Now compare the melting point of chloride of Busherian and carbon for oxide. So the melting point of Busherian and carbon for oxide. So now Busherian chloride chloride of Busherian. Remember, Busherian and chloride, they usually, when you react them, and they form a bond called an ionic bond, which has because it's a metal and a non-metal. So ionic bond is usually very hard to break, and therefore it has a high melting point. For carbon 4 oxide, these are non-metals, and most of the non-metals are bonded using something called weak intermolecular forces or weak van der Waals forces of attraction. Now, and since they are bonded using weak intermolecular forces, it is very easy to break, and that is why its melting point is going to be very low, even below 0 degrees Celsius. Now, so in short, you're told to compare and then explain. Busherian chloride has a higher melting point, has a higher melting point. Okay, has a higher melting point than carbon dioxide. So you've compared it. Then carbon dioxide. Tayari hiyo ni 1 mark. Half a mark yaweza kuwa. Then carbon dioxide. Now you now explain the difference. Utasema explain it. Barium chloride, which is BuCl, is an ionic compound. And ionic compounds normally have a high melting point. So is an ionic compound, sorry for that, is an ionic compound, okay, with strong electrostatic forces, because it has strong electrostatic between the positive ion and the negative ion, with strong electrostatic forces. While CO2, while carbon dioxide is a simple molecular substance, with weak intermolecular forces, So yeah, that is why the melting point of the chloride of Busherian is high. So just leave it this way and you get 2 marks. Okay. So question F, compare the electrical conductivity of Busherian in solid state and in solution form. Now in solid state, ionic compounds normally do not conduct because it's in solid state. So they do not conduct. But in solution form, they conduct because of the free mobile ions. Okay, but let's compare it still because it's more about writing. So let's write it down. So in solid state, does not conduct electricity. Why? Because ions are normally fixed. Because ions are fixed. Huwezi yani ukazivunja. So we have maybe, let's say sodium chloride. Hii kama hujazivunja ikiwa in solid state haiwezi conduct because there's no mobile ions up. The ions are fixed there together, so they do not move from one point to another. But in aqueous state, since it's polar, it's going to be attracted by the polar part of water. So in aqueous or maybe in molten form, but say in aqueous solution, or let's say in aqueous solution or in solution form, it conducts electricity. The reason why it conducts electricity is because the ions are mobile at the time. Conducts electricity because, what am I doing? Because ions are free to move, or they are mobile. Let me just write it, are free to move or mobile. So you have free mobile ions. So question G. Hii pepa iko na maswali mingi mpaka sahii nimechoka. Compare the ionic radius of Busherian and its atomic radius. Now Busherian, just compare, sio, si lazima Okay, let's kwa sababu hasijui the specific one, kwa sababu iko chini ya potassium, maybe it's going to have 288 8 18 labda 1. But all in all, hii ni muhimu. So we'll assume iko na 4 energy levels. So for now we'll assume there's 4 energy levels. Nje kuna 1 electron. Lose, because Busherian is an atom, it has a tendency to lose. So here, atomic radius is the distance from the nucleus of an atom to the outermost electron. So this is the atomic radius. So if it becomes an ion, it loses 1 electron. So ukiona hizi zilikuwa 4 energy levels, sahi itakuwa 3 energy levels, because 1 electron is lost and the energy level is also lost. So itakuwa ni 3. 1 2 3. So zimekuwa 3. Umeona? So 1 energy is lost. So the energy, if it is lost, then it also means the radius will increase. And therefore, this is the ionic radius. The ionic radius will tend to be very smaller compared to the atomic radius. So ukitoa shell moja, you're reducing the radius. So when it becomes an ion, it reduces the radius, and therefore the ionic radius tends to be smaller than the than the atomic radius. So again, atomic radius is larger. Atomic radius is larger than ionic radius. So atomic radius is larger than ionic radius. So Busherian, which is Busherian plus, okay, loses its outer electron. So when it's in ion form, it loses its outer electron, and at the same time, losing the outer electron, it also loses the shell. So loses outer electron, also the shell or the electronic shell. Therefore, reducing in size. Therefore, reducing in size. So that is the best answer. The other answer maybe was sema kwa vile ilikuwa na 11 electrons when it was Busherian atom, lose itakuwa ni Busherian plus. So it's going to become 10 electrons. So electrons are fewer. Ikiwa ni fewer, so the nucleus will tend to pull the electrons towards the nucleus. The electrons towards it. So ikianza kupull hile electron towards it, the size will also decrease. So the other reason may be that as well. So kwa vile electrons zimepungua, protons are many. Since the protons are many, it means that the shell, the electrons outside will be pulled towards, or it will have a stronger nuclear pull, and therefore reducing in size. Tumeelewana. Now compare the ionic radius of Busherian with that of sodium, and I believe that the Busherian is below potassium, so as well is going to be below sodium. So the Busherian will have a larger ionic radius than sodium. Busheria will have a larger ionic radius than that of sodium. That of sodium ion. Okay, and the reason is because it is below potassium. In group 1, and therefore it will have more electron shells compared even to sodium. So, and therefore has more occupied electron shells. Acha tuandike more occupied electron shells or energy levels. Kuna wengine labda hata hawajui shells nini. So occupied shells, electron shells, or energy levels. Energy levels pale ambapo electrons za move. So kama vile tumesema Busherian itabakia na 3 energy levels, hiyo ikiwa ni ion. Sasa sodium yenyewe ikiwa ni ion itabakia na 2 shells tu peke yake. So just imagine 2 shells versus 3 shells, which one is will have a higher radius? Obviously the one with 3 shells. So that is your answer. Question 19, hatujachoka, sijamaliza hata. Now question 19, oxonium ion, which is OH3 plus, as the following structure. Label on the structure, label on the structure. Roman 1 covalent bond. So covalent bonds are these ones. Hizi hapa ndo tutaita covalent bonds. Sawa. Hizi ni covalent bonds. So again, let me write it this one. So hizi mbili ndo covalent bonds. Just write this covalent bond. Na wacha tuziandike zikiwa pamoja. So these two are covalent bonds. So that is done for the first one. Now label coordinate bond. Coordinate bond is a type of bond, is a type of covalent bond that usually it involves sharing of electrons, but the one that is usually distributing the shared pair of electrons is one. Not both of them are distributing. Only one of the bonding atoms is distributing the shared pair of electrons. Ni kama vile Ali ako na viazi vya shilingi 20. Sawa, na yeye pia atakakula. Na kuna mwenzake Imran, ikiwa ni Ali na Imran pia ni nzuri. So Imran hana lolote, 0 shillings. So Ali atakakula na Imran also needs food. So what Ali will do, he will share with Imran. So Ali atapata, Imran atapata. But Imran hajatoa lolote. So that's a dative bond, one of the examples of dative bond. So hapa ukiona oxygen na hydrogen, hii part hapa, ukiona this part, hii yaonesha kuwa oxygen amempa electrons kwa hydrogen, but they're sharing those electrons. So this is a dative bond or a coordinate bond. Ni sawa? Tuko pamoja. Question B. Explain why a water molecule can bond with H plus to form oxonium ion. Sawa. Hii hapa iwe H3O plus and oxonium ion. So explain why a water molecule can bond with H plus to form oxonium ion, and it's very simple. That is because water, just imagine water iko hivi, so water is something like this. Now oxygen iko na ni 2,6, so iko na yahitaji 2 pairs, na hydrogen ni 1, obviously it requires 1 pair, so itampa 2, itampa 1 pair, itampa 1 pair. Now if you take 6 minus 2, you're going to remain with 4 in oxygen. So oxygen atabakia na 4 kabisa. So since oxygen still has a lone pair, bado oxygen iko na electron, so hydrogen plus ikija, because hydrogen plus doesn't have electrons, itakuja itachukua electrons kutoka, itaanza kushare na oxygen, because hydrogen plus doesn't have any electron. So why a water molecule can bond with H plus to form oxonium ion is very simple. It's because water in itself will have a lone pair. Lone pair ni zile electrons ambazo hazitumiki katika bonding. So it's going to have 2 lone pairs. So water has 2 lone pairs which will bond with the hydrogen ion. So water has 2 lone pairs, 2 lone pairs of electrons, 2 lone pairs of electrons. Tulikuwa na 2 lone pairs juu na chini. 2 lone pairs of electrons on oxygen, kwa sababu oxygen ndo walikuwa na hizo lone pairs on oxygen, which are donated to H plus to H plus to form a coordinate bond. Tosha hii. And therefore producing this H3O plus. Nimechoka leo. Now, question 20. The diagram below is a section of a model. Sawa. Kuna question ngapi sahi? The diagram, lakini wametunga maswali mingi. Hata grade 10 haifai watungie maswali haya bana. Biko mingi sana. Kwa nini enter ama ni The diagram below is a section of a model of the structure of element A. I don't know which element is that. Now plus minus, I think this is metallic bonding kwa sababu wana kuna plus na minus. Now question A, state the type of bonding that exists in T. So obviously kama nilivyosema, ukiona kuna plus na kuna minus, wewe jua tu hiyo kitu ni what do you call it? Metallic bonding. So, very simple. So hiyo ni metallic bonding. So, and to which group of the periodic table does element T belong to? Is group 1. So, group 1, give a reason is very simple. Ukiona kila atom iko na electron. So, it does 2 electrons ama vipi? Ionic, okay? This I think it's group 1. Okay. Is it group 1? No, it seems like group 2 to be fair. So it seems to be group 2 because I see it has 2 electrons, but the drawing doesn't yani because I'm seeing 5. Okay. In a pool of how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a pool of 5 to 10. So it's at around 1 to 2. The Manisha, one proton is drawing in 2 electrons. So most probably in each atom there's 2 electrons. Give a reason because each atom has 2 delocalized electrons. Okay. Question 21. Well, kuna question 22. Wow. Ni nyingi. Sema kaa watungia. Wacha tumalize. Question 21. The table below shows atomic and ionic radii of some elements represented by letters R, S, and T, S, T, and U. Okay. This ones. Classify, study it, and answer the questions that follow. Remember, these are not the actual symbols. Study it and answer the questions that follow. Classify element U as a metal or a non-metal. Explain U. So, U, is it a metal or a non-metal? For me, nitasema ni metal sababu atomic radius ni kubwa kuliko ionic radius. So U is a metal. Now, that is because the ionic radius is smaller. For metals, usually the ionic radius is smaller. So ionic radius is smaller than atomic radius. Then its atomic radius. So it shows that showing it forms a positive ion. So showing it forms a positive ion by losing electron. By losing electron. So kwa sababu lose electron, it'll lose for metals, when they lose electron, they usually lose their outer shell. So kama ilikuwa ni hivi, ilikuwa ni moja, kulikuwa na shell mbili. So and just imagine hapa ni 2 1 maybe. Saa hii ikilose moja itakuwa ni 2 peke yake. So this one, the atomic radius is bigger than the ionic radius. So if they lose, they give you a positive ion. Now, which of these elements is the strongest reducing agent? Is the strongest reducing agent. Strongest reducing agent. Now, oil rig. Oxidation is normally losing electron. Reduction is normally gaining electrons. So, now, the one that gets oxidized usually loses electron. So it's called a reducing agent. So a reducing agent, in short, is the one that loses electron. So reducing agent most of the time is the one that is more reactive. So the one that is at the top of the reactivity table, that is potassium followed by sodium and calcium, magnesium. Those are usually reducing agents, and most of them are metals. Now, so which of the following elements is the strongest reducing agent? And that is so ile ambayo iko na atomic radius kubwa ndo sasa is the strongest reducing agent. So S is your stronger. Umeona haija kuuliza explain, just state. So kwa nini the S is the, kwa sababu ile ambayo iko more further or which has a larger atomic radius, electron yake can be easily lost, because a strong reducing agent is the one that loses electron easily. So electron yake iko more easily lost. So the one with the large atomic radius loses its electron much easier compared to the one which is smaller. So S, which element forms an anion? An anion is the one that gains electron. In short, ile ambao ionic radius yake ni kubwa kuliko atomic radius yake ndo itaform an anion. So the one that gains will have a smaller ionic radius compared to, no, it's going to have a larger ionic radius compared to atomic radius. Let's say, for example, fluorine. Fluorine ni 27. Fluoride ion again itakuwa ni 28. Lakini do you believe that its ionic radius is bigger? It's going to be bigger than the atomic radius. Why? It's because once you gain electron, it will have a repulsion on the nucleus. Kwa sababu umeongeza electron, itakuwa na a higher strong electronic repulsion, and therefore the electrons will move further from the nucleus. Ikienda mbali sana, yamaanisha the radius will start to increase. So the one that usually has a larger ionic radius, which one has a large ionic radius than its atomic radius, is this one. Ionic radius yake ni kubwa kuliko atomic radius, and therefore element T. So element T. Question 22. Ioni tag. Question 22. Explain why water has a higher boiling point than both ammonia and hydrogen fluoride, although all of them have hydrogen bonding. A very good question. Now water has a higher boiling point, because each water molecule forms more extensive hydrogen bonds. Creating a stronger intermolecular network. Than ammonia and hydrogen fluoride. And hydrogen fluoride. Yeah, nimeandika nyingi so that you guys can able to understand it. And therefore you require more heat energy is required to break it. More heat energy is required to break it, or to break the water molecule. Now let me explain it. Water iko na higher boiling point because each water molecules forms more extensive hydrogen bonds. Sawa, ukiangalia hydrogen fluoride na ile ya water is very different. Hydrogen fluoride ni HF2 na ammonia ni NH3. Sawa, ile ya water ni H2O, in which ukiangalia vizuri the hydrogen bonds in water, they usually create a stronger intermolecular forces because they form extensive hydrogen bonds. Hydrogen bonds zake si similar kama vile ya ammonia na hydrogen fluoride, and that is why you require a lot of heat energy to break it down. The last question, nimechoka hata where, but this is the last question. The diagram below represents parts of the structure of a sodium chloride crystal. The position of one of the sodium ions in the crystal is shown as plus. Okay, it's shown as plus. It's shown as plus. So on the diagram, mark the position of the other 3 sodium ions. Ukiona kama ni plus, obviously hapa kutakuwa na minus, minus, minus. So hapa tutakuwa na plus, minus, and you have another plus here, sawa, and then another plus. So itakuwa chonjo. I think that is the final answer. So that marks the end of our lesson. Sawa, so let's call it a day. Mimi hata nimechoka hata. So also don't forget to subscribe to the channel, share it to your friends, and in case you want to reach out to me, obviously this is my number. Okay, just you can reach out to me, but also watch my other videos, especially in the upload chemistry topic 3, I think topic 2. I don't know if it's topic 2 or topic 3. I think it's topic 3. Then followed by other topics, especially about the periodic table. So you upload, you'll see it. And also I'll upload another chemistry paper, inshallah, bi'idhnillahi ta'ala. So again, just stay tuned in maana grade 10 kuna vitu vingi nita upload, especially term 3. Term 3 wako kuna vitu vingi vipya. So stay tuned in. Tuko pamoja. So inshallah, have a lovely day. Don't forget to subscribe.